All right. So, gentlemen, today we are going to be talking about setting up number one, the example for current lab part two in Tinkercad so that you guys can walk through this. I'm going to show you a couple of the common issues that we run into, and then you guys are going to work on that. And then after you're done with that, you're going to get started working on Ohm's Law Lab 1. So, one thing that's really important here when we start talking about amperage is, remember, amperage is the amount of electrons that pass a point in a given second, right? It's the current or the flow of electrons. And remember, electrons are always going to take the path of least resistance. So if we allowed the electrons a choice to not go through the ammeter, but like go around the ammeter, we're not going to get an accurate number. The other problem with measuring amperage is that the amp meter itself doesn't have much resistance, practically zero. So if you put the ammeter in parallel, you're going to be bypassing most of your circuit and it's not going to work. So I'm going to show you guys like the example here. I'm going to show you what not to do. I'm going to show you what you should be doing, and then you guys are going to get to work from there. So I'll open this up. And we shall start. All right, so I'm just going to delete all of these wires here for the moment, and then we'll just talk about setting this thing up. So one thing that I'd like you guys to recognize right now is I do have one 10,000 ohm resistor here, but I also have one 5,000 ohm resistor here. So the answers that you're going to see on my screen are not the right answer, okay? I'll show you the process that we're going through here, but then you're going to do it yourselves so that you can go through it also. So at this point, we have a battery, we have a breadboard, we have a multimeter, we have two resistors. Again, yours would both be 10 kilo ohms. And then we have an LED. So let's talk about LEDs here real quick. In real life, if we were going to have an LED, and if we were to look at the LED from the top, the LED would kind of look like a, well, I shouldn't draw it like that. The LED would have a flat side, and then it would have a circular side. The flat side to the LED is the negative side of the LED, okay? Light emitting diodes, an LED, a diode is basically has polarity, and it's a one-way street, okay? So when we look at this, we can kind of see the rounded side of the LED. That's the positive side of the LED. And then we can see the flat side of the LED over here. That's the negative side. Cathode is the negative side of an LED, or anything for that matter. And the anode is the positive side of the piece. So if you think that you have your circuit set up properly, you might have your LED backward if it's not working. So the first thing I'm going to do here is I'm going to bring my LED somewhere into my circuit, okay, like say right here. Okay, so again, the flat side of my LED is the negative side, and I have my battery connected to the bus bar on the side. So I have my negative bus bar and my positive bus bar. So because this is the negative side of the LED, I'm going to connect a wire between the negative bus and that lead. And I'm going to change this color to be black. Now, when we go back to here, pop that in there. We're coming out of our negative. We're now going into our LED. Okay, so that part's done there. And we're going to continue around through like a wire, through some sort of a conductor to the first resistor, then through another conductor to the second resistor. And to begin with here, we're just going to skip the ammeter altogether. So no, that's not what I want. When we come through here, we again are going to go through some sort of a conductor, which in this case, the conductor is the row, right? The electrons come up, they go through the LED, they hit row, in this case 16. They come between the anode of the LED to 16A, where they pick up the resistor, and now they're running over to 20A. We take our second resistor, which, once again, not the right value resistor here, but we take that, and anywhere within this row 20, whether it's in 20E, 20D, 20C, 20B, doesn't really matter, there is an electrical connection between the first resistor and the second resistor. So now we've run to the end of this resistor, and again, we're going to just start off ignoring the ammeter altogether, and we're just going to complete our circuit. Okay, because you could have issues with your ammeter, you could have issues with your circuit. It's best to minimize the amount of variables that you have within the problem to start with, and just make sure that things are correct. So right now, the LED is on, things are working, so that's pretty great. Once again, if my LED was set up backwards where the positive, the anode, the positive side was connected to the negative, and I go to start my simulation, it does not turn on because electrons can't pass through. So we got to make sure that that's going in the right direction, and then it will turn on. So oftentimes, this is what you really don't want to do, but this is something that students do all the time. They will take an ammeter. First of all, before I even get into this, when you click on your multimeter, make sure that you're changing the mode to be amperage. So they'll take the ammeter and they will connect the ammeter up in parallel with the circuit. And then they're going to get this right here when they start their simulation. So let's take a look at what we have here. First of all, the LED is not lit up anymore. Okay, so we know that there's something wrong because the LED was just lit and now it's not, so we know that there's an error. The other thing that we have going on right now is this thing is reading 6 amps of current, which 6 amps is a lot of current. Like all of the light rooms in my class probably run on less than 6 amps worth of current. So they certainly run on less than that in this instance here. So remember, electrons take the path of least resistance. So as electrons come out of our battery and they jump across this black cable, instead of going through the resistor, or I'm sorry, through the LED, then through the resistors, which is a lot of work for them, they shoot through the ammeter instead, which has very low resistance. And then they come back to the positive end. What we've done here is we've created what's called a short circuit. And a short circuit is when you complete connection between the negative and the positive that you didn't mean to, and now are no longer connecting to the rest of our circuit. We have to, and as it says here, or shows here, we have to connect these in series, which means we're going to force our electrons to go through here. So that's pretty easy to do once you get the hang of it. Once we've tested our circuit here and it's running, we need to break our circuit apart to put our ammeter in series with the rest. So I'm going to take this positive leg here, but it could be my negative leg also. It doesn't really matter. I'm going to connect the positive to the positive. Okay, if I was going to grab the negative leg, I'd connect the negative to the negative. Okay? Then, whatever you just disconnected, right? Like that wire was in port A24 or 24A. Whatever you just disconnected, now you're going to create a new wire and you're going to connect from there to the opposite terminal in our multimeter. Now when we go through, we have negative coming through here. It's going to come up, it's going to come around. We're going to go through the first resistor, through the second resistor, through the negative port, through the ammeter, back to the positive terminal here. So now when we start this, we're reading 481 microamps of power. Now again, that answer is not correct because it's not the right resistors, but nonetheless, the circuit here is correct. Now, from here, you would move on to answering your question, right? You'd first calculate your resistance for that one, and then you'd put down the measured amperage, and you'd observe how bright the light is. The light is not that bright here. Then you would move on to the next one and you'd set them up in parallel. Notice that the ammeter and the LED are still in series. As electrons come around, they go through the LED, then they split between two resistors. They reconvene again, go through the ammeter, and then to the positive side of the piece. Okay, I'm not going to show you guys how to do that. You're going to work on it, but if you have questions, you can ask me. And then again, down below, you're going to write the calculated resistance and then the measured amperage. Once you move on to step number 3, you're going to be answering in full sentences, including as much information as you can, and use technical terminology that we have discussed in class. So the question is, what is the difference between circuit 1 and circuit 2? Why is one of them brighter than the other? Okay, and you're going to go through and answer those questions as you go along. Okay. Once you've finished that, then you can start Ohm's Law Lab 1. Ohm's Law Lab 1 is going to be due tomorrow. And, you know, as people finish it up in class, they'll be able to leave tomorrow during class here. So whatever you get done on that today just means that you're better off for tomorrow. Okay, so that's this here. Ohm's Law Lab 1 is completely calculations. You're just going to make sure that you use with this, make sure you use the magic circle, E, which is voltage, I over R. Be careful with this answer here, or this question down here. That question in a calculator, it's going to give you an answer, and I don't know exactly what it is. Let's say that it's like 0.5, which it's not, but it'll say like 0.5 to the E negative, and I think it's to the -8. This just means this is scientific notation. It means you're going to take the decimal point, you're going to move it back 8 places, then you're going to convert that to be a metric prefix. If this was a positive number, then you'd move your decimal place to the right 8 places. But since it's negative, you're going to move it to the left 8 places. Okay? Make sure all your answers are converted to metric prefixes before you do your calculations and after you do your calculations. Okay? So today's a work day. As questions start popping up, you guys can